So now I wanted to explore how many solutions a linear system might have. First, I wanted to consider a 2 by 2 system, which when we say 2 by 2 system, what we mean is a system with two equations involving two variables. So just a quick example of some such system might be x minus y equals 2, and then x plus 3y equals 5, something like that. Now notice that an equation like x minus y equals 2 could be rewritten as y equals x minus 2 if we isolated the y. I just want to remind you that a linear equation involving x and y can be represented graphically as a line. Each of those equations represents a line. And so there are three possibilities here. The two lines might intersect in a point, which would give us a single solution. And I'm going to abbreviate solution here to keep this video short. The two lines might also be parallel, in which case there is no solution. There is no point common to both of those lines. Or the two lines might lie right on top of each other, in which case there are infinitely many solutions. Every point on that line would be a solution to the system. Now, we could extend that to a 3 by 3 system, a system of 3. We may also look into this graphically for a 3 by 3 system. So that would be a system of 3 linear equations involving 3 variables. If you've taken Calculus 3, you've seen this, or you will see this when you take Calculus 3, that an equation, let's just consider the first one, an equation that's linear in x, y, and z can be represented graphically as a plane. We typically draw planes as parallelograms with the understanding that this parallelogram extends in every direction, kind of along this sheet. It's an infinite sheet. So one option, if we drew these 3 planes, is that they intersect in a single point again. So it's possible that there's a single solution, and this is what that would look like in 3-dimensional space. It's also possible, so the same way we saw this with lines, that the 3 planes are parallel. And so these infinite sheets kind of lie one on top of another and never intersect. So there is no point that's common to all 3 planes, and so there's no solution to that system. A third option, and this can happen a number of ways, but draw it here, is that these 3 planes intersect in more than a single point. Which I'm attempting to draw here. It gets a little tricky, but so in this case, I'm attempting to illustrate 3 planes that intersect in a line. It's also possible that these planes might lie just right on top of each other. The 3 equations might essentially describe the same plane. In this case, there are infinitely many solutions. Okay, I'm going to abbreviate down here. One last thing I want to point out here. So a consistent system is a system that has one or more solutions. A system that has at least one solution is a consistent. This is an E. I apologize for my writing in these videos. So a consistent system has one or more solutions. And I'm going to abbreviate solutions here again. So the single solution scenario, the infinitely many solution scenario, either of those describe a consistent system. A solution that a system that has no solution is called an inconsistent system.